Very good afternoon to all of you and welcome to today's live coaching classes. We are taking up a very interesting chapter in statistics today, and that is the chapter on probability. This is a very interesting chapter. We have very pointed examples in the study materials which will help you to understand the entire concept and the type of questions we expect in the exams we shall be discussing. This is definitely going to be very interesting for all of you. Now, the discussion flow, we have two sessions on probability. The first one we are having now, and the second session we shall be having on 28th of February. So the discussion flow, we will first move on to understand what is meant by random experiment. And there are different terms in probability. So probability means the likelihood of occurrence of an event. So we shall learn about the different terms, the definition of probability, the main formula which we use, and the concepts of mutually exclusive, exhaustive, and so on. And after that, we will move on to understand the different formula we need to use for calculation of probability of an event. Next in line will be the discussion on conditional probability, which is an important part of this chapter. And expectation, mathematical expectation, is another very important integral part of this chapter, which we need to understand. And the last, we probably in the next session, of course, we will move into the discussion of variables. Variables, all of you know that there are two types, discrete and continuous. We will look at the different type of behavior of these variables, both discrete and continuous, and we shall try to understand their properties, the nature, and so on. At the end, we shall devote ourselves to understanding the type of questions which can be expected, problems and solution from set A, B, and C. So very interesting and intellectually stimulating chapter, and that is probability. Also, please remember, quite a number of problems in the exam are expected from probability, and that is why two sessions have been allocated to handle, to understand, and to learn about probability. So in the discussion, we shall also cover some important questions which are there in the mock test paper of the Institute, the CAMTP. The first concept to understand is the learning objective, why we are learning probability. Now, if you look at the type of discussions we had in the measure of central tendency and dispersion, we first started with an understanding of why we need to learn this particular chapter. Now, in the field of accounting, audit, and finance, the concept of probability has a wide use, a very extensive use of the concept of probability. Why? Because probability deals with the likelihood of occurrence or non-occurrence of a variable. So it helps in developing financial forecasting. For example, what can be the share price of a particular company in the next, say, for example, next week, or what is the probability that a bank loan will turn into a bad debt, like a bad loan. So all these financial forecasting are done by chartered accountants extensively using probability as the underlying principle, and the main technical focus is given on probability. Like in banking, a loan is given, but the loan is defaulted. So the probability of finding the default. Then many of you know that when a loan becomes a bad loan, it is known as NPA, non-performing asset. So the probability of non-performing asset, the probability of fraud which can take place. Then in audit, now in accounts you have already learned about financial statements, but then in audit you will be learning later on the chance of getting material misstatement in financial statements. So what is the probability that one part of the financial statements, balance sheet, profit and loss statement, cash flow, they contain wrong statements, or they contain some figures which are erroneous figures, or figures have been manipulated. So even probability in audit, to a large extent, we depend on the probability theory from statistics. Similarly, in a manufacturing setup, say in a factory, in a plant, any manufacturing location, every company wants to find out the probability of defectives. So if there is a production going on, what is the probability that the items which are being manufactured, they are actually, they confirm, they comply with the standard. That means they follow the standard. What is the probability that there is a defective item? So even in factory, in production floor, this concept is widely used. This general framework of probability is used. Then another important area in risk management. So what is the probability that a particular IT system will fail or a particular control is going to fail? So in risk management, in decision-making theory, probability is used widely in all types of financial and mathematical models. Similarly, the probability of the pandemic, the probability of a war, all of you have seen what is happening in Ukraine. So the probability of a war, probability of winning a match, different type of probabilities. Whenever we have the idea of calculating the likelihood of an event, all these are events. A fraud taking place or a war, a pandemic, these are all types of events. So probability of winning a match, a cricket match, for example. So this is guided by probability, and it's an application of the principles of probability. Another example is, say, when you think of the weather forecast. So, for example, how does the weather department, the weatherman, the Indian meteorological department, IMD tells us that, okay, probability that it's going to be sunny is 70%. So you know that, yes, 70% chance means 0.7 probability. So definitely it is going to be sunny. So they might tell you that there is a 20% chance that it might snow. So from all these chances, 20%, 15%, 80%, well, we get ideas about the likelihood of that event. So all this which you see on this slide, you can appreciate that all these are examples of probability, and probability deals with the likelihood of occurrence of an event. Okay. So probability of raining, absolutely, yes, Komalakshmi. Probability of raining. Okay, so definitely when you think of probability of thinking, yes, what is the probability that you will think and you will solve the problem correctly? Probability of passing an exam, very important for you. I'm sure all of you are putting in so much of hard work and efforts to learn about all these subjects in foundation. I'm sure definitely with your efforts, you will be successful. So the probability of success may be 80%, 90%. But if I do not study, say I am a student who's not very serious about studying, I don't follow the live classes of the institute, I do not refer to the study materials, then maybe the probability that I will fail is 80%. Okay, so that means it's the maximum, the higher chances that I will fail. So probability gives us an idea about the outcome of an event, and therefore very, very important. Probability of cards, yes. One more example coming from Mayur. Yes, probability of cards. Yes. Then there is one point from Jaspreet, whether income from share market is good in future or not. Yes. How much will a person gain from the share market? Already, based on our discussion so far, you can understand any event. So how will the market perform? How is the stock market going to perform in future? Okay, so these are all guided by probability, and different models are there. Okay, Shiba has said probability of a patient recovering from a disease. Yes, absolutely. Probability of tossing a coin, Komalakshmi. Yes, that is the most common example, and we will discuss about coin tossing in a few minutes. Absolutely. So it is basically the probability means the chance or the likelihood that an event will happen or it may not happen. So Dhyanesh has given an example. He has written, sir, probability means happening or non-happening of an event. It means contingency. See, nobody knows the future for certain that, yeah, this is going to happen. But we can find out the chance. That is why probability means chance. Probability means likelihood of any type of event which might occur, which may occur or may not occur. Okay, so let us look at the formal definition of probability. So you can see the different terms which I was using a little while back in this slide. You can see probability in all likelihood. It can mean chance. It can mean odds in favor. So probability has different ways of expression. The ultimate concept is chance or likelihood of an event. And then another point, of course, is that probability has now developed into a full-fledged subject. It is, even though it is a part of statistics, but then you will find, like, say, central tendency, measures of dispersion, which we have completed. So you see, these are important pillars, important integral parts of statistics, and probability theory is a very significant part, very important part of statistics. It is now looked upon as a separate subject. Okay, so probability is the chance that something will happen. You can see in the slide. Now, if I say that there's a 10% chance of rain, then you will say that, okay, 10% chance means 10% chance is on the lower side. That means it may not rain. But if I say it is an 85% chance that it is going to rain, then you know it is almost certain. Almost certain. The degree of chance has gone up. The degree of probability has gone up. So if you look at this particular picture, which is there on the slide, you can see that when we say that the probability is 0, that means it is an impossible event. So it will never happen. Similarly, when there is a certainty that yes, this event is going to happen, so we say probability is 1 out of 1. So please remember, when we write probability, probability has a maximum value of 1 and the minimum value it can take is 0. So very important point is that probability is less than equal to 1 and it is greater than equal to 0. So if it is it's an impossible event, then definitely you can say that yes, it is 0, probability 0. On the other hand, if you say that no, there is a certainty. For example, now many people were talking about World War III, right? So like Abdul has written about probability of World War III. Well, to some extent already we can see there is an attack and things are becoming complicated. So yes, it has happened. So the probability is 1. It is certainty. Yeah, probability in many examples are coming. Muhammad Ali has said probability in crypto, probability in stock market. Okay. Dhyanish is asking, is it very hard? Senior students say it is very hard. No, no, no. Just follow the session. You will find it is as easy, as simple to understand as the other chapters in statistics. Okay, if you have followed statistics so far, I'm sure probability will not be any type of difficulty for you, and the probability that you will get high marks in the mathematics paper will be very high. I can assure you of that. Okay, so just be more positive and make sure that you put in all your efforts to understand the discussion. Okay, there is one example from Abdul. Sun rises in the west. Well, it's 0 probability. Okay, yes, you can say it is impossible event, so it is 0 probability. Okay, good. Now let us look at the study material. What our study material is saying, the ICAI study material states that at the foundation level, the concept of probability is used in accounting and finance, which I was mentioning. Why? Because we need to know the likelihood or the chance that an event will take place or not, like passing an exam, for example. So it helps in developing financial forecasting, like, for example, the financial condition of a company, the cash position of a company after 1 year or 2 years. So forecasting what will be the revenue of the company, what will be the net worth of the company. So all these are based on probability. It is based on uncertainty to some extent. So therefore, in the advanced level of chartered accountancy course, you will be studying all these concepts, these subjects and topics. So therefore, the probability chapter in statistics in foundation helps you to have the knowledge, helps you to understand how these theories are actually put in practice. Okay, now who developed probability? So there were many experts, for example, Sir Isaac Newton, the well-known scientist. He is credited to be amongst the first who started thinking about probability. You know that he had a very thinking mind. You all know the story of that apple. So he was the person to think about gravity, the power of gravity. the force of gravity. He was basically instrumental in bringing a lot of concepts, including he's credited to be one of the first mathematicians to introduce or to think about calculus. Now, in probability, we will see some, even though Newton had the first, he brought in the first idea that yes, there can be something called mathematical probability. It was later on Laplace of France and Reverend Thomas Bayes, based on whom, in fact, Thomas Bayes, there's a theorem called Bayes theorem. This is basically in the name of Thomas Bayes. And later on, R.A. Fisher of England, they were actually responsible for developing probability as per today's, the way we understand it today. Plus in Russia, now again we come to Russia, so Kolmogorov of Russia and many other noted mathematicians as well as statisticians, they developed the concept of probability. So probability theory has been developed down the last 700 years by several mathematicians and scientists, and you can understand even probability has so much of implication, so much of application, apart from finance, accounting, auditing, banking. It has so much of application in the medical world. For example, when you are buying a life insurance policy, the life insurance company knows that, okay, what is the probability that a person aged, say 25, will fall sick in the next 1 year, as a result of which there will be a claim on the life insurance company. So, we pay the premium for our life insurance policies. But then the probability that a person, say, will die or meet with an accident or a person faces an injury, all these probabilities are computed, are calculated by life insurance companies. So you can see it has a tremendous industry level application in virtually all sectors you can think of. Okay. Right. Many of you, yeah. Many of you are writing very good examples of probability. Okay. Now the concept is probability is chance, likelihood, and now we come to the first term, which is called random experiment. An experiment is defined to be random if the experiment results, that is the outcome, depend on chance. The best example is when you take a coin and you toss it, tossing of a coin, or when you throw a dice. You're playing with a dice, for example, you throw the dice, it can have, you might, just like a coin, you have head and tail. Similarly, in case of a dice, you might end up getting a score of 1 or 3 or 5 or 2 or 4 or maximum 6. So when we are drawing or rolling a dice, or when we throw a coin, we either get head or tail. In a dice, we can get 1, 2, 3, 4, 5, and 6. So these are called random experiments. For example, drawing a card. Many of you might be playing cards. So from a pack of well-shuffled cards, so out of 52 cards, if you bring out a card, so, or if you draw 2 cards out of 52, this, what will be the type of card? Is it a spade? Is it hearts? So all this will be decided by probability, and these experiments are called random experiments. Why? Because the results depend only on chance, absolutely on chance. So even if you talk about the experiment like a startup business, will it be successful? Okay, what is going to be the fate of a startup which is, say, for example, operating, which has just started its operations, a typical business startup? Will it be successful? So a success of a business startup can also be similar. It can also mean random experiment. So we can think of a startup, which is, say, for example, a business venture. So whether it's going to be successful, it could be a random experiment. Similarly, the probability, or say, for example, a person falling sick or a person meeting with an injury, well, whether he's going to recover or not, these questions also will be like a random experiment. So when the outcome depends on chance, right? So this is the concept of random experiment, which is the first important term which we are learning. So an experiment may be described as a performance that produces certain results For example, when you toss a coin, you get two outcomes, head and tail. Is it a random experiment? Answer is yes. Why? Because before you toss the coin, it is not possible to say with 100% certainty which one will come, whether you will end up getting a head or a tail. So it depends on some chance, uncertainty factor, chance factor. Therefore, tossing of a coin is an example of a random experiment. Absolutely. So Ankit has stated experiment example of probability of coins. Absolutely. Okay. Abdul is asking if in the exam this question is asked, who developed probability? You can talk about Laplace, Fisher. Of course, you will get the MCQs, so you will get the options. So please remember that the modern form of probability has been developed by Laplace, Fisher, and also definitely Kolmogorov from Russia. Okay. Probability of happening an event. Possible, yes, if it is Bhumika has written. Yes, as I wrote here, probability 1 means it is not possible only, it is certain. It is certain, then only the probability will be 1. And it will be impossible event when you find that the probability is 0. Okay. Now let us look at some examples. Now, events. So we have seen what is random experiment. We have gone through the understanding of random experiment. Now let us understand what do we mean by events. Events means the results or an outcome of a random experiment. So if I say the tossing of a coin, what is it? It is a random experiment. It can have two outcomes. These are known as events. And event number 1 can be head. Event number 2 can be tail. Okay. So event means it is the outcome of a random experiment. Please note. Yeah, rolling dice is an experiment. Yes, Priyanka, rolling dice absolutely is an experiment. So when you roll a dice, it's an experiment. It's a random experiment. What will be the events? So here, friends, let me also share with you the idea of sample space. Very important. When you are tossing a coin. So I'm just writing coin tossing. Is it a random experiment? Answer is yes. What will be the event? The event can be either head or tail. I'm writing within second bracket. This way of writing it, this is called the sample space. Sample space. Sample space means all the outcomes, all the results which can take place in a random experiment. Once we write it, it's called sample space. This is number 1. Let me take the second example. Say you are throwing a dice, you are rolling a dice. So I will write roll of a dice. What will be the event? The event can be, there can be 6 types of events. It can be either 1, you can end up getting 2, 3, 4, 5, and 6. So we can say there are 6 events. And this is also known as the sample space. This way of writing, this is called the sample space. So what is sample space? Sample space is the collection of all the results or of all the events which can take place out of a random experiment. That is called, you can call it sample space, you can also call it event. Okay. So now let us move on. And events can be simple or it can be compound. Event is a simple event if it cannot be decomposed into further events. For example, when you toss a coin once. So tossing a coin once provides us 2 simple events. It can be either head or tail. So it's a simple event. Then what is a composite event or a compound event? Composite event can be decomposed into 2 or more events, right? So an example of this composite event is getting a head when a coin is tossed twice. It's an example of a composite event. Why? Because when you toss a coin twice, you are tossing the coin 2 times. What can happen? You can either get, it can be split into head and tail, tail or head. Okay. So the question was getting a head. That means you are tossing the coin 2 times. So this can be further decomposed into 2 subsequent events. And either it is HT, that means either the first throw gives you a head The second throw gives you a tail, or it can be TH. TH means the first throw gives you a tail and then you get a head. So head tail or tail head. So this is an example of a composite event. Absolutely. Right. Okay, so Dhyanish, I hope you have understood. You have asked what is the difference between probability event and random experiment. Probability is the occurrence or the likelihood or the chance of any event. What is event? Event is the outcome of a random experiment. What is random experiment? Random experiment is a particular experiment whose outcome depends on chance. So random experiment is the input. Output is what? The events. And how to measure the events? The process of measuring events is probability. Because how much will be the chance that an event will take place? This is the definition of probability. Right. So I hope you have understood these simple three terms. First is random experiment, second is event, and of course, the definition of probability. Now, quickly we move into three further ideas and terms. Mutually exclusive events. Mutually exclusive event means that occurrence of one event means that the other event cannot take place. For example, when you are tossing a coin, you get two events which are mutually exclusive. That means together, both of them cannot occur. When you are tossing a coin, it is either head or tail. When I sit for an exam, I will either pass or fail. There is nothing in between. And I cannot fail and pass together. Similarly, I cannot get a head and tail together. It is either or, either head or tail, either pass or fail, either one or two or three or four or five or six when I'm rolling a dice. It cannot be all of them together. So that is called mutually exclusive events. Okay. So, yeah, composite events, Manisha, composite event means any event which is broken down into further events. So if it is said that, I was explaining that what is, when we are talking about getting a head, you have two coins, or you have, let me take three coins now. Okay. So if you have three coins and you are tossing those three coins and you want to get a head, one head. So what can be the opportunities? In case of two coins, we know it can be either HT or TH. Okay. So if you get HT and TH, in both the cases, what you are getting one head. So this getting one head is nothing but a composite event. Why? Because this composite event can be broken down into number one situation, number two situation. So getting this one head when you are tossing two coins, well, it depends on these two situations. Situation one, that you have got head, and situation two is, first situation is you got head and then tail. Situation two is you got tail and then you got a head. Right? So that is why it is broken up. This particular event which you see here is broken down into these two events. How can I get one head when I'm tossing two coins? Situation one, either first coin gives me head, second coin gives me tail, or it can be first coin gives me tail and second coin gives me a head. So these two ultimately give rise to one head. So this event is a composite event because it breaks down into these two subcategories, situation one and situation two. Okay, so I hope now you are able to understand. Right. Now let us move on. Next is exhaustive. Exhaustive events means that one of these events must occur. When you are rolling a dice, either one or two, it has to occur. When you are thinking of, say, it is let me talk about a space mission. Okay, I'm just taking some examples. A space exploration or a space mission, it can have two results, success or failure. An exam, okay, it can have success or failure. Say, for example, a match, any sporting match. In case of a sports tournament or a match, Either you win or you lose or there is a draw. So I've given some examples here. Space mission, either successful or failure. Exam, either success or failure. Match, either you win or you lose or there is a draw. So all these, you can see, these are exhaustive events. For example, for space mission, success and failure, this success and failure, both are exhaustive because one of them has to occur. Similarly, for exam, either you get a success or you fail. Either you are successful, you pass or fail. So here, success means passing. So either pass or fail. In a match, either you win or you lose or there is a draw. So here, one of these events has to occur. That is why these are called exhaustive events. And finally, you have equally likely events. What is the example of equally likely events? Well, when you are throwing a particular, say, when you are tossing a coin, there are two events which is possible. Either it can be head or tail. That means if I ask you, what is the probability of getting a head? You will say 50%. So there are two options, right? And I'm asking you, what is the probability of getting a head or a tail? You are saying that, okay, getting a head is 50%, getting a tail is 50%. So these are examples of equally likely. So coin tossing is an example of an equally likely event because it can give rise to two events. One is head, the other is tail, and both have the same likelihood, both have the same chance, both have the same probability. That is why it is called an equally likely event. Okay. Pushpa is asking why not HH? Not HH because it was told that you need one head. If you get HH, then there'll be two heads. The question was, how can I get one head when I'm throwing two coins? Okay, so HH will not be considered. Okay. So you can think of all these. Ultimately, say a company's business, either it's profitable or it's loss making. A startup, either successful or fails. There is no in between, right? So if there is an accident, say in a space mission, well, it is not successful in that case, definitely, because loss of astronaut, for example, or say, for example, it's nothing called, in statistics, there is nothing called partly successful. Either you make it or you not, or you don't, right? It's just like an exam, either pass or fail. There is nothing called in between, partly successful, no, nothing like that. Either you make it or you don't. Similarly, when you're tossing a coin, either it's head or tail. There is head and tail cannot occur simultaneously. Similarly, when we are, say, for example, rolling a dice, we cannot have more than one, either one or two or three, or more than one faces we will never get. So either one or two or three or four or five or six. We cannot have multiple faces together. So that is why these are mutually exclusive, exhaustive, and equally likely. So equally likely means, once again, I'm explaining, equally likely means when the events have the same probability. For example, if I take the case of, say I'm taking rolling of a dice. So rolling of a dice means what? So you can either get one or two or three or four or five or six. So how many possibilities are there? There are six possibilities. 1, 2, 3, 4, 5, 6. If I ask you, what is the probability of getting 5 when you are throwing or when you are rolling a dice? So 5 means only this one. So then you will say that out of 6 possibility, getting 5 means 1 by 6. So the probability becomes 1 by 6. But if I ask you, what is the probability of getting more than 4? Same situation. If I ask you the second question now, this is question number 1, and I ask you the second question, what is the probability of getting more than 4? More than 4 means either 5 or 6. That means here you have two events which can be in your favor. But total number of cases is 6. So the probability will be, denominator is 6, but the numerator becomes 2 by 6, that is 1 by 3. Okay, so this is basically, here you can see equally likely. All of these are equally likely. Getting 4, getting 3, getting 2, getting 6, all are equally likely because they have the same probability, 1 by 6. When you are tossing a coin, you have two events, either head or tail. What is the probability of getting a head or tail? It is 1 by 2. That is half. Okay. So this is how we understand the three important principles. One is mutually exclusive, the other is exhaustive, and the last one is equally likely. Yeah, 1 by 6. Many of you have got it. Yes, Manisha, thank you. Shiba, Jyoti, yes, 2 by 6. Bhumika has written, throwing a dice, no one will get 7. Yes, so its probability is 0. Okay, so if you get a question like this, that what is the probability of getting, say, 7 or 8 when you are throwing one dice? Not possible. So it is a 0. It's an impossible event. Probability is 0. Okay. Okay, there's one question from Abdul. If a movie got hit, nor blockbuster, nor flop, can we say it's partly successful? Yes, we may say, but in statistics, that cannot be handled. Here we have to discuss about only those events which are, they have to be mutually exclusive. So if it is a flop, that there's no concept of partly flop, partly hit. Some viewers liked it. There's no concept. Either it is a blockbuster, it's successful. Think of it not from these subjective parameters, but from objective. In an exam, either we pass or we fail. Is there any other way? Can I pass and fail together? No. Can I be partly successful in an exam? No, either I have passed. Getting 50% also means you have passed. Getting 99% means you have passed. Both are technically passing. Similarly, if I fail, say 50 is the pass marks, I have got, say, 49. And another person has got 10 out of 100, and I have got 49. Both have failed. Maybe I have got higher marks than him. That doesn't make a difference here. The fact is, both of us have secured less than 50. We have failed in the exam. So ultimately, it is a question of either pass or fail, either head or tail, either getting one. So it's mutually exclusive. And you will see that without the type of concept of mutually exclusive, we cannot arrive at probability. Okay. Exhaustive events, Jana Lakshmi, please note, exhaustive events means one of them has to occur. Exhaustive events, like I was taking the case of this, when you're rolling a dice, one of them has to occur. Mutually exclusive means that if one of them occur, the other cannot occur. For example, if it's a head, you cannot get a tail. Exhaustive means together, head and tail together will give you the complete sample space. So for example, here 1, 2, 3, 4, 5, 6, one of the 6 has to take place. So this is an exhaustive event. Okay, but then when we say that there can be some situations like one of you were asking about a movie, say a movie. Well, movie, it will be very subjective because you may not get parameters to measure the success of the movie. And there can be number of outcomes which can take place, which may not be mutually exclusive. So in that case, it will not be considered for statistical purposes. Okay, but in case of statistical purposes, please note that the classical definition clearly tells us that number of mutually exclusive, exhaustive, and equally likely events divided, which are favorable to A. So if I ask you in this example, I have taken the same example here. Now we will understand the formula for probability. If I ask you that, okay, what is the probability of getting, you are rolling a dice, what is the probability of getting a score less than 4? Less than 4. So what is the probability? First of all, the probability, if you see this slide, probability formula is a fraction. The highest number can be 1, the lowest can be 0. When probability is 1, we will call it a certain event, and when probability is 0, we call it an impossible event, right? So when we are talking about probability, it's a fraction. Now the question is, what is the fraction? How will you write it? The total number of events which are favorable divided by the total number of events which can take place. In our example, the question is, and these events, please note, will be mutually exclusive, exhaustive, and equally likely. Here also in the denominator, it is the total events which are mutually exclusive, exhaustive, and equally likely. So please remember these terms: mutually exclusive, exhaustive, and equally likely. Now, looking at 1, 2, 3, 4, 5, 6, if the question goes like this, what is the probability of getting any number which is less than 4? So you are rolling the dice once. So what is the total number of events which can take place? It can be 6 events, either 1 or 2 or 3 or 4 or 5 or 6. 6 events. Now the question is, which events are favorable for you? The question clearly says that the numbers should be less than 4. That means what? That means if I get less than 4, it is favorable for me. Less than 4 means what? Either you can get 1, or you can get 2, or you can get 3. So there are 1, 2, and 3. 3 cases which are favorable. So I will write 3 in the numerator and 6 in the denominator. So my probability is half. 3 by 2 is 1 by 3 by 6 equal to 1 by 2. That is half. 0.5. So this is how we are measuring probability. And this particular theory which you see, it is the formula. The definition of the formula has been developed by Bernoulli and Laplace, and it is known as the a priori definition. A priori definition, and it tells us the probability is a ratio or a fraction. The numerator will be the events which are mutually exclusive, exhaustive, and equally likely, but it is favorable to a particular, the favorable number of events. And in the denominator, we have the total number of possible events which can take place. Like in our example, the favorable events are 1, 2, and 3. And the denominator will be the total number of events which are possible when this experiment is carried out. So here, of course, the experiment is rolling of the dice. How many cases or how many outcomes can take place? How many events can take place? It is 6 events. So 6 comes in the denominator and 3 goes to the numerator, because 3 getting either 1 or 2 or 3, that is our favorable event. Okay, so I hope it is clear and you have understood. Okay, yeah, many of you have got it right, 1 by 2. Okay, if a startup, now there's one question from Sarvesh, if the startup has to get success or failure, is it a mutually exclusive? Yes, if it gets success. Now, if success means it has to be successful, means it to get some measurable way of finding success, not the general way of generic way we say it's successful. Success means, say, IPO. All of you know Zomato has gone for an IPO. Nykaa has gone for a successful IPO. Okay, so if you get an IPO, say we are measuring IPO as a measure of success. In that case, either the company makes an IPO or it is not allowed to go for an IPO. Yes, it will become mutually exclusive. That means if one takes place, the other will not take place. Okay, definitely. Yeah, 1 by 2. Excellent. Shreya, Hera, Dhyanesh, Piyush. Very good. Also, we have Manisha, then Janalakshmi, Bhumika, Naveen. So many of you have got it. Also, Muhammad Ali, Priyanka, Abdul. Very good. Okay, exclusive breaking news is the example of mutually exclusive event. Can you explain that? Exclusive breaking news is the example of mutually exclusive event. Well, exclusive breaking news. So when a news comes up, well, how can you link it with mutually exclusive? Mutually exclusive means one of the events must occur. Okay, so event means it's an outcome, right? Outcome from what? Outcome from a random experiment. The first concept is random experiment. This gives you certain outcomes. These are known as events. Events must be mutually exclusive, that if one of them takes place, the other cannot take place. Okay. So this is the classical definition of probability, which we have understood, and we have taken an example to illustrate and analyze. So classical definition: number of equally likely events which are favorable, and these ideally are mutually exclusive also and exhaustive. And in the denominator, we have the total number of events which are likely, exhaustive, and mutually exclusive, of course. So this is the formula which is there in the study material: PA equal to M by N, where M is the number of favorable events, or you can say events which are favorable to A, and In the denominator, we get the total number of mutually exclusive, exhaustive, and equally likely events which can take place. Okay. Now, there is one concept for complementary event. Complementary event means event of a failure. If you have the event of, say, I'm giving you a particular example, that probability of success in an exam, say the probability of success in an exam is, say, 30%. Okay, probability of success. What is the complementary event? So the complementary event means the event which is the complement of this particular event. So it is the other way around. If it is success, then the other will be failure. So the complementary event, that is PS dash, will be simply equal to the total probability maximum value is 1. So it will be 1 minus 30%, that is 1 minus 0.3, that is 0.7. So the probability of the complementary event is given by 0.7. Also, we have already checked that when we talk about a certain event, or a sure event, we call it probability is 1, and the probability for an impossible event is denoted as 0. Okay. One more question based on which you get one more concept we will clear up now, based on which number of questions are coming. The ratio of number of favorable events to the number of unfavorable events is known as odds in favor of the event A. So if I tell you that the odds in favor, say I'm saying that odds in favor of rainy weather, I'm writing odds in favor of rain, say is, I write 3:2. The odds in favor of the rain is 3:2. Then you can write basically the probability of a rain is equal to 3 divided by 3 plus 2. That is 3 divided by 5. Please note this. Okay. So the odds in favor will be, the probability of rain will be 3 divided by 3 plus 2, that is 3 by 5. Okay, so the ratio of number of favorable events to the number of unfavorable events, favorable to unfavorable, that is called odds in favor of the event. And in this case, the odds against the rain, okay, so it will be P, say P rain dash. This is equal to 1 minus 3 by 5, that is 2 by 5. Okay, so this is how we find out that probability, how to get the probability from odds, from the odds in favor. So odds in favor of an event will be basically the ratio 3:2 or 7:5, whatever, or 8:3, 8:1, whatever. So from there, you can easily find out the probability of that event taking place. Yes. Yes, Priyanka, full subscription of an IPO. Yeah. Chandan has said clear, crystal clear. Thank you. IPO full form is initial public offer. Vinita, IPO full form is initial public offer. Okay. Abdul is asking which chapter has most weightage value in statistics. Most weighted value, if you talk about, probability is one of them. Okay, one of the most highly weighted. Weightage is very high for probability. Also, theoretical distribution is another chapter which we'll be learning after probability. Now, there are multiple types of theoretical distribution. You have binomial, you have Poisson, you have normal distribution. So from there also, high weightage is given in the exam. Okay. So you can see an example here in this slide. You can see that 0.25 means unlikely, 0.5 is 50-50, 0.75, when the probability is 0.75, we can call it likely event. And when the probability is 1, we can call it it's a certain event. And probability 0 means it is impossible. Right. Let me go to some illustrations. A coin is tossed 3 times. What is the probability of getting 2 heads? So let us try this one. A coin is tossed 3 times. What is the probability of getting 2 heads? First question is 2 heads, and the second question is at least 2 heads. Okay. Okay, I'll take complementary events. Will do, Dhyanesh. Will do many of them. Complementary events means the other complement. That means, say, if I tell you that the probability of getting, say, when I'm throwing or rolling a dice, the probability of getting one or say three when I roll a dice is how much? 1/6. What is the complementary event? The complementary event is what? That I will not get one, I'll not get three. So when I'm rolling a dice, say for example, the probability of getting three is 1/6 when I'm rolling a dice. So what is the complementary event? So the complementary event is that probability of not getting three. Not getting three means what? You can get any other number excepting three. It can be 1, 2, 4, 5, and 6. So the probability is 5/6 because there are 5 ways in which you can get any number other than 3. Right? I hope you are clear. Okay. Yeah, at least 2 heads. So let us do this one. We will first take some questions from the study material and then we will move on to some additional questions as well. So when we are throwing when a coin is tossed 3 times, please see through the tree diagram, it can be either head, 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 HHT, HTH, HTT, THH, and you can see the others. So the number of elementary events is 8. Okay. The coin is tossed 3 times and the number of elementary events is 8 because there are 8 ways in which you can toss 3 coins. You can see 1, 2, 3, 4, 5, 6, 7, 8. Now, out of these 8 outcomes, 2 heads, if the question is exactly 2 heads, 2 heads are appearing either in HHT or HTH or THH. So the probability is 3/8. Right? I hope this is clear. 3/8. Yeah, many of you have got it right. Jyoti, index number will be there later on. Jyoti Jha, your question is index number and correlation not covered in syllabus. Index number will be there, I think, in March. Okay, possibly I will be taking your session on index number. Correlation, I am not very aware about that. Just check the schedule. But index number I'll be taking, so I know that will be in March. Okay. Right. Now, at least 2 heads. Second question is at least 2 heads means what? At least 2 heads means either 2 heads or 3 heads. So 2 heads you are getting in how many ways? You are getting in 3 cases. That's why we got 3 out of 8. So if I ask you, what will be, how many ways you can get 3 heads? 3 heads will be only once. There is only one opportunity to get 3 heads, that is HHH. So in the second part of the question, the answer will be 3/8 plus 1/8. So you will be getting, that is basically 4/8. So the answer is 0.12 or 1/2, that is half. Okay, 0.5. That is the answer for the second part. Yeah. Okay, let's move on and check the next question, which we have. A dice is rolled twice. What is the probability of getting a difference of 2 points? Very, very interesting question and important for the exam. Very similar question can be expected in the exam. Kindly note, in case of probability, you don't have to draw all those tables, not much of calculation. It is intelligence. Understanding the concept, applying the formula, and then getting the answer. You don't have to do much of calculation here. Okay, it's mostly a fraction. So in all the cases, you will find a fraction. Of course, in case of mathematical expectation, it can be a whole number or it can be even a negative number. But of course, for probability questions, only for probability, it will be fractions. So here the question is, a dice is rolled twice. What is the probability of getting a difference of 2 points? So when you are rolling a dice 2 times, what are the number of total number of outcomes? So the first dice can roll in 6 ways and the second dice can also roll in 6 ways. So total 36 ways. 2 dice can be rolled in 36 ways. Now the question is, what is the probability of getting a difference of 2 points? A difference of 2 points. How can you get difference of 2 points? That means the difference can be like this. I'm just drawing one illustration here. Say you get 2 and 6. first dice. So I'm writing D1 and D2. Dice 1 is D1, dice 2 is D2. So 2 and 6, 6 and 2, first case. You can get, say, for example, 5 and 1. The question is, what is the probability of getting a difference of 2 points? Sorry, 2 points. So it can be 2 and 4, 2 and 4 and 6. I'll take it this 4 and 6, 6 and 4. It can be 5 and 3, 3 and 5. Then also you will get a difference of 2. It can be 4 and 2, 2 and 4. Also, you will get a difference of 2 in this case. The question is, in how many cases you will get a difference of 2? Difference between the score will be 2. So 4 and 6, 6 and 4 we have taken. 5, 3, 3, 5 we have taken. 4, 2, 2, 4 we have taken. Another situation can happen 1, 3, 3 and 1. Here also you will get a difference of 2. So when you are throwing these dice, it can be the following. You can see here, there will be number of cases 6, 4, 5, 3, 4, 2, 3, 1. So we have taken 6, 4, and we have taken 1, 2, 3, 4, 5, 6, 7, 8. 8 cases can happen. Also in the slide, you can see there are 8 cases which can take place. So total events is 36. Total number of favorable events is 8. So the probability becomes 8 by 36. And you can break it up and simplify it. The answer becomes 2 by 9. Okay. So this is also a fairly simple question, and we can easily solve it just by understanding what will be the, when you are throwing the dice, what will be the score, so that you get a difference of 2. Okay. Now this is a card problem, very important question which has come in the mock test paper as well. What is the chance of picking? Yeah, very good. Priyanka has given all the details. Thank you, Shreya, Jyoti. Then we have Chatan, Dhyanesh, Bhumika, Naveen. Naveen also has got 2 by 9. Excellent. 8, yeah, good. Right. Now let us see this question. What is the chance of picking a spade or an ace, not of a spade, from a pack of 52 cards? Now, to understand the card problem, we have to just take a note of what is there in a pack of cards. So you know that a pack of cards contains 52 cards, and it has 13 spades, 13 hearts, 13 clubs, and 13 diamonds. And each of these groups of 13 cards will have an ace. So in this example, which is very, very relevant for the exam, the total number of elementary events is 12. So if I just draw it like this, just to explain the problem. So you have 4 categories. You have spades. I'm writing spade here. You have hearts, in short H. You have diamonds, D. Okay, and you have the clubs. So C. This is S. Let me make it S. Okay. And each of them has an ace. So there is an ace here, ace here, ace here, ace here. Okay. So we have to pick a spade or an ace, not of a spade. So we have to pick a spade or an ace which is not of a spade from the pack of 52 cards. So the ace in 13 spades, the ace in the 13 spade is treated as a spade, and therefore the formula here becomes 16 by 52, because you are picking one card. So there are 52 cards. So denominator is 52. Total number of possible ways of picking a card is 52. Now, which are the favorable ones? The question is picking a spade or an ace. So how many spades are there? There are 13 spades. Okay, so we are having 13 spades. So I'll write 13 spades here. And then we have 3. You can pick an ace not of the spade. So 13 plus 3 is 16 by 52. So you get 4 by 13 as the answer. 16 by 52, correct. 4 by 13. Next question, let me move on. A committee of 7 members is to be formed from a group of 8 gentlemen and 5 ladies. What is the probability that the committee would comprise 2 ladies, and the second one at least 2 ladies? So please note, this is a question on combination. You have already completed the discussion of permutation and combination. This question is a direct application of combinations. So you see, in mathematics and statistics, I always keep on telling you that each of the chapter is so important, because the knowledge which you gain in that chapter will be helpful in a future chapter. For example, when you practiced permutation and combination, you must have done it in detail, because now you have to use that knowledge. Similarly, the knowledge which you are gaining now in probability chapter will be useful for you when you move to the next chapter, and that is theoretical distribution. If you don't understand probability, you will have difficulty in understanding theoretical distribution. So all these chapters are linked with each other. Okay, that is the beauty in mathematics. It's like building it's like a building. So each of the stories you are creating, and the foundation has to be strong, then only you will understand the remaining chapters, the remaining stories you can build up. So here, the probability of creating a committee, there are 7 members to be formed, and there are 8 gentlemen and 5 ladies. So first of all, we have to find out in total how many people are there. So we need to get first the total number of events which can take place. 8 gentlemen, I'm writing 8G, and 5L, that is 5 ladies. So I'm getting total 13 people. 8 and 5 is 13. So if you have to form a committee of 7 members, how can you do it? So the number of events, the number of possible events is 13C7. So 13C7, you know factorial, so it comes to 11 into 12 into 13. Now the question is, we need 2 ladies. 2 ladies. Now 2 ladies means there will be 2 ladies in the team. So that means out of 7 members, 2 will be ladies, and the remaining 5 will be gentlemen. Okay. So now how many ladies are there? You have 5 ladies. So the question is 2 ladies. It can be selected in how many ways? 5C2. Out of 5 ladies, you are selecting 2 of them. 5C2. Okay. Now the question is, if you have 5C2 here, you are having 5C2. So ultimately, we can write that you have to also understand that out of the remaining people, now you have taken ladies, 2 ladies out of 5 ladies. The other committee members are how many committee members? 5 committee members. So the 5 committee members have to be selected from the 8. Those 5 committee members are male, that is, they are gentlemen. So you have to select it from 8. So ultimately, this combination will be 5C2 into 8C5. Okay, because you have 5 and 2, 7 members in the committee. 2 are female, 2 are ladies, 5 are gentlemen. So ultimately, the answer will be 5C2 into 8C5 divided by this one, 13C7. So you can get the answer. Whatever comes, you can just try it out and check. Okay. Right. Okay. So this is basically how we solve this problem. Next one, if you go, just check this. The next question, let me take. This was at least 2 ladies. So this is a related question. Now we move to 2-3 formula which we need to keep in mind. We have 2-3 formula which we have to keep in mind. So the first one is P A union B. So this we had done way back in set theory. You may remember that we discussed about set theory in one of our chapters in mathematics portion. So what is set theory? You know, and here we are discussing about some important formula. So P A union B is equal to P A plus P B. Just note the formula. Similarly, for 3 events, P A union B union C, it is basically P A plus P B plus P C. So 2 events will be exhaustive only when total probability is 1. So 2 events A and B are exhaustive means P A union B has to be equal to 1. Similarly, 3 events are exhaustive when P A union B union C equal to 1. Okay, so you have to remember that. And the third one is 3 events are equally likely when PA equal to PB equal to PC. So this is nothing but a direct application of set theory. And this is basically, these are the formula based on which we will be solving the problems. Okay. Now let us go into the next question. Okay. Yeah, Kashish, we took, you see, the question was on the number of committee members. So you have 8 gentlemen, 5 ladies, and now you have a group of, basically there are 7 people. So first of all, 7 people can be selected from 8 and 5, 13 members are there. 8 gentlemen and 5 ladies, total 13. In how many ways can you select 7 people out of 13? It is 13C7, which is written in the denominator. Now, the question says exactly 2 ladies. I'm doing the first part of the question. The question says exactly 2 ladies. Exactly 2 ladies means the remaining 5 people will be gentlemen, because total number is 7. So if you take 2 ladies, 7 minus 2, 5 means the gentleman. So 2 ladies can be selected from how many? 5 ladies are there. So 5C 2 ways. Multiply that by the remaining number of members. The remaining members are 5, and all 5 must be gentlemen. How many gentlemen do you have? You have 8. So 8C5 gives you the required amount, the required number. So in the numerator, we are getting 5C2 into 8C5. Okay, I hope you have understood this. Okay. Okay, one question has come from Shreya. What is an ace? Okay, ace actually, if you play cards, you will know it. And ace is basically, it's a playing card with a single pip. Okay, you can just find is a single suit symbol, either heart, diamond, spade, or club. It is located in the middle of the card. Okay, in the middle of the card, you will get it. That is called an ace. And is sometimes, it is decorated. For example, if I draw an ace, this question has come from, let me check. The question has come from Shreya Mundul. Okay, Shreya, please note when you draw, say there's a playing card here. I'm just drawing it. So say when you have a thing like this in the middle. Okay, I'm just drawing a club, or say any particular type of character. Okay, so when you have this in the middle, say I'm just writing A here and A here. Okay, so this is type of card is called an ace. Okay, I hope it is clear. Now let me go into the next question, the next formula which we need to remember, and that is very, very important. P A union B, we have done this. This is equal to PA plus PB minus PA intersection B. So we will use this formula. Let's go into some problems first. Acha, sample space, we had already discussed about it. Random experiment. So sample space is given by 1, 2, 3, 4, 5, 6. When you are throwing a dice, when you are rolling a dice, it is absolutely, the sample space is given by the 1, 2, 3, 4, 5, 6. Okay. Next is, okay, let me take some problem. Intersection of 2 events. Yeah. Intersection we already know from set theory. We know that the intersection of 2 events means the common point of 2 events. So if the 2 events are mutually exclusive, that means if one happens, the second one cannot happen. In case of mutually exclusive events, what will happen? PA intersection B will be 0. Why? Because there is no common point. If one happens, the other will not happen. So ideally, the 2 events will be disjoint, A and B. So there is no common part. Okay, therefore, A intersection B, probability of A intersection B is equal to 0 because there is no common portion. Both the circles are separate. They are disjoint circles. Okay. So as I said, that if P A intersection B is 0, that means if 2 events are mutually exclusive, then it has to be P A intersection B has to be 0. Okay, why can't it be that ladies are 6 and man 1? In the last example, this question is coming from Neha. Let me just go and check. I'll go to the previous example. Okay, yeah. Committee of 7 members. 7 members, there are 2 ladies. The question is 2 ladies. So you are asking, why can't it be that ladies are 6 and men are 1? How can you have 6 ladies? Please check the question, Neha. There are 5 ladies. How can you create, when you see, it's given already that committee of 7 members is to be formed from a group comprising 8 gentlemen and 5 ladies. So if you have 5 ladies only, then in the committee, how can you take 6 ladies? I hope, Neha, you have got it. Okay, 7 members are to be created. 7 members committee has to be formed. And it is given that there are 8 gentlemen and 5 ladies. So the question is, what is the probability that the committee would comprise exactly 2 ladies? Right? And therefore, at least 2 ladies, of course, is a separate question. But when I'm talking about 2 ladies, even if you take at least 2 ladies, it will be the following situations. At least 2 means 2 ladies, 3, 4, and 5. You cannot have 6 ladies. You cannot have 6 ladies and 1 gentleman. Why? Because you have ultimately got 5 ladies only, from where you have to select the ladies. So from, if you have 5 ladies, how can you select 6 out of them? So Neha, I hope you have understood. Neha Yadav has written the question many times. Okay. Now let me go to some more examples. Yeah, there is one more question, one more theory which we just complete, and that is, that we have done already. Conditional probability we will see after some time. This also we have done. Okay. Acha, this is a very, very, very important question for the exam. Please note this carefully. Please note this carefully. This is a lovely question from the Board of Studies and something which is very important. It is such an intelligent question that you have to apply all the formula which we have learnt till now. Please note the question. 3 events are ABC are mutually exclusive, exhaustive, and equally likely. What is the probability of the complementary event of A? All the questions, all the theory, the formula, or the explanation which we have discussed till now are applicable in this single problem. It is such an important problem. So kindly note and please be very clear in understanding this. 3 events are mutually exclusive, exhaustive, and equally likely. What does it mean? It means that they are mutually exclusive. That means A, B, and C. If A happens, B will not happen. If C happens, B will not happen. So first of all, we can write, plus they have written it is exhaustive. So we can write that P, A union B union C. We can write this, since they are mutually exclusive, we can write this is equal to PA plus PB plus PC, number 1. Number 2 is their exhaustive. Their exhaustive means PA plus PB plus PC, probability of A plus probability of B plus probability of C equal to 1. Exhaustive means this, I'm writing E and ME. Mutually exclusive means that A union B union C is equal to PA plus PB plus PC. Second question is exhaustive. Exhaustive means total sum has to be equal to 1. And number 3 condition is equally likely. I'm writing EL, equally likely. Equally likely means each of them have the same probability, that is PA equal to PB equal to PC. So please try to see all these relations which I have written on the board. So 3 events, they are mutually exclusive. That means P A intersection B intersection C will be equal to PA plus PB plus PC. The second question says they are exhaustive. Exhaustive means together the sum has to be equal to 1. We have set the probability equal to 1. And the third question is they are equally likely, which means PA equal to PB equal to PC. That means what is the probability of A, event A? Total is 1 and each of them are equal. So I can say probability of A is 1 by 3. That is, I'm breaking 1 into 3 parts. 1 part, 2 part, 3 parts. So probability of A is 1 by 3. So therefore, what is the probability of the complementary event of A? So I can write, if PA equal to 1 by 3, then PA dash is equal to PA dash is 1 minus 1 by 3, that is 2 by 3. So the answer is 2 by 3. Please note how we have arrived at First is mutually exclusive. So this is the formula we are getting. Second is it is equal to 1. Third condition is equally likely. So I am writing PA equal to PB equal to PC. So if each of them are equal and if the sum is equal to 1, that means you can easily come to the conclusion that probability of A equal to 1 by 3. Why? Because 3 of them equal together become 1. So therefore each of them is equal to 1 by 3. So if probability of A is 1 by 3, then the probability of the complementary event, A dash, is 1 minus 1 by 3, that is 2 by 3. It's a very significant question for your exam. So kindly note, that is how we have got it. The answer is 2 by 3. Yeah, probability will be 2 by 3. Many of you have got it. Equally likely, yes. Yeah, we see A union B union C we have taken here because it is mutually exclusive. So it follows that there is no mutually exclusive means there is nothing called intersection here. Intersections will be 0. Okay, since it is given in the question, we have discussed it here. Next question is some additional theorems are there. P A union B. Now, let me take this question now. This is an example, solved example, 16.9. A number is selected from the first 25 natural numbers. What is the probability that it would be divisible by 4 or 7? 4 or 7. So first of all, you have to look at 4 or 7 first 25 numbers. So this is another important question. Now we will try to first look at the multiples of 4. What is the probability that it will be divisible by 4 or 7? The question is 4 or 7. So let us find out first which one will be favorable for 4 and which one will be for favorable 7. Now, if you look at the numbers 4, 8, first 25, so you can go till 25. Now, for 4, if you look at the multiples of 4, you have 4, 8, 12, 16, 20. Also, you can take 24 because it is less than 25. Now, for 7, in order to be divisible by 7, the numbers will be 7, 14, 21. So, we are getting the sample space. For 4, it is, how many are we getting? So, now, please note that the question is the number is selected from the first 25 natural numbers. Now, out of 25 numbers, how many can you select? I mean, in how many ways can you select one number out of 25 numbers? So we can select in how many ways? We can select in 25 ways. Out of this 25, how many numbers are there which are favorable for 4? Please note 1, 2, 3, 4, 5, 6. 6 numbers are there. How many numbers are there which are favorable for the next condition, that is 7? The condition is the numbers are 7, 14, and 21. So we have 3. Do you have any common numbers here? Answer is no. There are no common numbers. So we are getting ultimately six numbers which are favorable for getting 4 or multiple of 4, and 3 numbers which are favorable for getting 7 and multiple of 7. So therefore 6 and 3, 9. So the probability is 9 by 25. We are getting the probability 9 by 25. So roughly around 0.36 is the chance, is the probability. Okay. Yeah, many of you have got it. The last question you got it correct. Jaspreet, Dhyanesh, Abdul, Anchal. Yes, very good. Okay. Here it is 4 or 7. Yes. Okay. 9 by 25. A coin is tossed thrice. This is a very similar question. We have already taken it. So just see the problem here. The first question we took was based on the coin tossing. Already we have taken this 3 by 8. So this is simple, very simple. 4 by 8 basically it is a repetition of the last example which we have taken. Okay. Okay. Yeah, this also we have done 1620, that is P A union B equal to PA plus PB minus P intersection B. That we have already done in set theory, and it naturally follows from the set theory here. Right. This is an important question again. The probability that an accountant's job application has a BCom degree is 0.85, he is a CA is 0.30, and that he is both BCom and CA is 0.25. So out of 500 applicants, how many would be BCom or CA? Okay. So this is an interesting question again based on the direct formula P A union B. So let us just work it out and check how to arrive at the answer. So the probability that he is a BCom, I am writing B for BCom. This is equal to 0.85. Okay, 0.85. The probability that he is a CA, probability of a CA is 0.30, and the probability is both BCom and CA. So I'm writing probability that both BCom and CA, intersection sign. This is equal to 0.25. The question is, how many would be BCom or CA? That means we have to find P, B union CA. B union CA, B for BCom. So this is given by PA plus PB, that is in this case PB, that is 0.85, plus PCA, that is 0.30, minus intersection 0.25. So this comes to 85 and 30 is 115. 115 minus 25, so it should be, I think, 90. That is 0.9. Yeah, the answer is 0.9. If the probability is 0.9 and there are 500 applicants, so the number of members who are either BCom or CA will be how much? 0.9 into the number of applicants, that is 0.9 into 500, that will give you 450. Okay, so I hope it is clear, you have understood this one. Okay. Okay. There's one question in the last example, what will happen that 4 or 7? I will just come to that. So expected frequency, I hope you have understood this one, and this is how we arrive at the number of 450. Okay, now we will go to the last example. Let me see the question. Okay, that was 4 or 7. 16.9. What will be the probability of getting a number divisible by 4 and 7 in that example? 4 and 7. If you want to get 4 and 7, then you just add up again. Okay, you just add up all the numbers. Okay, 4 or 7 and 4 and 7. Here also it is 4 and 7. So you have to take, first you find out 4 and 7. It has to be, first you write down all the numbers. It was 4. I'm writing for 4 and now for 7. The question is 21. It's below 21. Let me write down. So it is 4, 8, 12, 16, 20, and 24. This is for 4. And now we have for 7, 7, 14, 21. Now please note, do you have any common numbers? You have to check for common numbers, because here 4 and 7. Now this question has come from, the question has come from Priyanka. Also a similar question has come from Muhammad Ali. Muhammad Ali is writing, if there is common number, then what we will do? If there is common number, you deduct that common number. Okay. Also, there is one more question from Dhyanesh, which says, if the number is repeated in both 4 and 7, then what is the answer? So I am trying to take this question once again. Please note in this example, 4, 8, if it is 4 and 7, that means you have to find those common numbers which is there in both the list. Unfortunately, if you see, there is no common number. So therefore, if the question as, let me see the last question who has written, what will be the probability of getting a number divisible by 4 and 7 in that example? Well, probability is that you are not getting any such number which is divisible both by 4 and 7. In fact, if you see, the first number which is divisible by 4 and 7 is 28, but 28 is not in the list. Therefore, it's the zero. The probability is 0 because you get no such numbers. Probability is 0. Okay, let me see. There is one question, 16.12. Some of you requested me to repeat. Jan Lakshmi also. Yeah, it is impossible. This one is impossible. No common numbers are there. Yes. Acha, let me go to 16.12. 16.12, what is the question? 16.12. Acha, why did I deduct 0.25? Okay. 0.25, you see, this was the BCom and the CA question. So please note, the question is saying, first of all, I will write the formula. So this number problem, I hope 4 and 7 you have understood. Now the formula which I was writing earlier, which you have learned, you remember we did that chapter on set theory. Now in set theory, we had done this problem. PA union B is equal to PA plus PB minus PA intersection B. Okay, here, what are the factors given? Please do this question once again with me. This is specially for explaining who has written. Let me see. Jan Lakshmi, also Kashish. Kashish, please check. Do it with me. Acha. Now you know that the probability for getting BCom degree. So it's a BCom. The person is a BCom. That is PB. B for BCom. Here is let me write 0.85. This is given to you. And probability that he is a CA, PCA is 0.30. The probability that he is both BCom and CA. Both BCom and CA means B for BCom, intersection CA. C, intersection. This is 0.25. You are told, what is the problem? The problem is asking you how many would be BCom or CA. So you have to find the probability of BCom, either BCom or CA. So basically what you have to find A union B, that is you have to find probability of BCom B union CA. B union CA is how much? First of all, it is PB, that is 0.85, 0.85 plus probability of CA 0.30 minus this P intersection B. So it will be what? Minus B intersection CA, BCom intersection CA. That means those people who are both BCom and CA have to be subtracted. They have to be reduced. They have to be eliminated. So ultimately it is 0.25 is subtracted. So you have P BCom, only BCom 0.85, only CA 0.30 and BCom and CA. So 0.25 is deducted. So you are arriving at 0.9. Okay, I hope now you are clear with this and you have understood the question. Yeah, there is one more question from Abdul. Yes, if the number goes to 30, yeah, if it goes to 30 and if it is question 4 and 7, then only one number will be there, 28. In that case, 28 is the only number, so the answer will be 1 by 30. Yes. Okay. Now we go to the last part of today, and before we go on to the questions, so this is dependent probability or joint probability. This is also known as conditional probability. Okay, conditional probability. Conditional probability is like this. It is called joint probability. So probability of AB will be equal to probability of A into probability of B by A. So it is written as probability of A multiplied by the probability of the event B, given that event A has already occurred. Okay, so what is the probability of event B, assuming that A has already occurred? So that is called the joint probability or the conditional probability or the compound probability. It's a very simple question, and the formula is very simple. PA intersection B or PAB is equal to PA into PB by A. Also, if you keep PB earlier, so it can be like this: probability of B into probability of A by B. That means probability of event B multiplied by the probability of event A, assuming that B has already taken place. So that is called conditional probability, and we will do some problems, then we will get a full clarity and full understanding of this question. Okay. Kashish, see the problem once again. Kashish, go to that problem once again. It is written here. I'll come to. Kashish is still not clear. Kashish, please see the problem. I have opened the slide. Please see. It is written here. He is both BCom and CA is 0.25. Just check this point. Are you clear? I'm waiting for you. I hope you are clear now. So it is given that the BCom, only BCom is 0.85, only CA is 0.30. Both BCom and CA it is given 0.24, 0.25 is given. That's why we subtracted 0.25. Right? Okay. Let us take some questions. Okay. Lot of theory are there. Achha, this is important. Rupesh is known to hit a target in 5 out of 19 shots. And David is known to hit the same target in 6 out of 11 shots. What is the probability that the target would be hit once they try both, once they are both trying? So this is interesting question. Two people are firing. They are hitting a target. Okay. Thank you, Kashish. Okay, I hope you have understood. Okay. Now, Rupesh is hitting a target. The probability that Rupesh hits the target is how much? 5 by 9. So I'm writing probability of Rupesh hitting the target. PR, R for Rupesh, it is 5 by 9. First question, first data which is given. Second question is David. David can hit 6 shots out of 11 shots. Probability that David is able to hit is 6 by 11. What is the probability that when both are trying, what is the probability that the target will be hit when both are trying? Okay, when both are trying. So please note this technique, how to solve this when both are trying. So first of all, we know that PA is given, that is the first event is given 5 by 9, second is 6 by 11. Now the question is, what is the probability that the target would be hit once they both try? Both try means what? Either Rupesh will hit or David will hit. That is the probability we have to find out. So here the question is, we first need to find out the joint probability. Okay. So P, probability that Rupesh and David both will hit, that is probability of Rupesh and David, PRD. This is equal to how much? 5 by 9 into 6 by 11. So that gives us 3, 2, 3 3s are 9. So it gives us 10 by 33. The probability that both of them are hitting. Now the question is the probability that it would be hit. That means we have to find out probability of Rupesh union David or union David. Either of them will hit. Either of them, how would you find out? First, let us add up their individual probability 5 by 9. PR is 5 by 9 plus PD is 6 by 11. 6 by 11 minus this intersection minus 10 by 33. Okay, now if you just take the LCM, that is 5 by 9 plus 6 by 11 minus 10 by 33, the answer will be 79 by 99. You can just work it out, take the LCM, and you will find the answer is 79 by 99. Okay, so this is also equally important for the exams, and I think you are now clear with this. From this question, I hope you can understand. Okay, Rupesh is known to hit a target 5 by 9. David is having the probability 6 by 11. When they are both trying, the question is that the target should be hit once they both try. So it can only happen, I mean, you're supposed to find out what happens when they both try. The target is hit. That means either of them hit the target, either of them. So it is probability of Rupesh union David or union D. This is a question of this is a question from this the last formula which we did, and that is compound probability, or you can say conditional probability. In a group of 20 males and 15 females, 12 males and 8 females are service holders. The question is, what is the probability that a person selected at random from the group is a service holder given that the selected person is a male? That means given that selected person is a male, so we have to find the probability that he is a service holder given that he is a male. Now, we can find out what is the probability. We know that probability of Sm. Okay, this is equal to probability of S into probability of S by M. Okay, we'll put it like this. This will be M into probability of S by M. Okay, so probability of both service holder and male is equal to probability of male into probability of service holder by male. This is the conditional probability which we have seen. That is the joint probability. So we have to find this part. So this part is how much? This part I can write as probability of S by M is equal to probability Sm divided by probability of a male. Now it is given that in a group of 20 males and 15 females, 12 males. So we have 20 males and 15 females. 12 males are service holders. So 12 males are service holders and 8 females are service holders. So 8 by 15. So we have to find out what is the probability of P S by M. So what is the probability that they are both service holders? So ultimately, probability of male, you can see, comes to how much? Probability of male, we are getting 20 by 35. So total number of people is 20 plus 15. Out of them, male is 20. So 20 by 35. So the denominator is coming to 20 by 35. And what is the probability that they are service holders? Service holders, we can find out. You can see how many are service holders. We know it is given. So how many are service holders? Out of 35 people, 20 males and 15 females, we can note that we have the probability that they are ultimately, the probability that the person is a male and he is a service holder, it is given by the probability of service holder and males. So here we can see the probability that he is a service holder and male is how much? 12. 12 out of 20 are service holders. So therefore the probability here is 12 by 35 divided by probability of being a male, that is 20 by 35 divided by 20 by 35. So it comes to 12 by 20. 12 by 20 means it is 0.6. So the answer is 0.6. So this is one example of the question on joint probability or conditional probability. Okay, there is one question regarding De Morgan's law from Dhyanesh. De Morgan's law we are going to do in the next day. It is very similar to what we have done earlier in set theory. You will remember De Morgan's law. Once I draw it, you will remember it. We will do it in the next session on our probability. That is on 28th, we shall cover De Morgan's law. Okay. Let us see this next question now and try to solve it. Mr. Roy is selected for 3 separate posts. For the first post, there are 3 candidates. For the second, there are 5 candidates. For the third, there are 10 candidates. What is the probability that Mr. Roy would be selected? Okay, so there are 3 positions. Please note there are 3 positions. Mr. Roy is selected for 3 separate posts. First post, there are 3 candidates. For the second, there are 5 candidates. And for the third, there are 10 candidates. What is the probability that Mr. Roy would be selected? So here, if you see, probability that he is selected for the first post, there are 3 candidates. So probability is 1 by 3. For the second, there are 5 candidates. So I can write for the second event, it is 1 by 5. And the third, there are 10 candidates. So probability C, PC is 1 by 10. What is the probability that Mr. Roy would be selected? So we will find out here what is the probability that he is not selected. And from there, we will use the complementary technique. So what is the probability that he is not selected? That is the first question we will find out. Okay. So here, what we will do is, this is an application of De Morgan's law, which I was just discussing. So De Morgan's law, we'll just note it here. P A union B union C complement is basically equal to P A complement into P B complement into P C complement. That is basically De Morgan's law. So this indicates that we will take the complementary values here. And if you take the complementary values, what happens is we have to find out, the question is that he is selected. So P A union B union C, we have to find out. So this will be equal to 1 minus probability that the complement. So this is equal to A union B union C complement. This complement which you see here, this complement according to De Morgan's law is equal to the probability of A complement into B complement into probability of C complement. Now A complement we can easily find out. A complement, if you see, we have the probabilities 1 by 3, 1 by 5 and 1 by 10. So we can easily find out probability of A complement is 2 by 3. Probability of B complement is 4 by 5 because 1 by 5 is the probability. So the complement is 4 by 5. And finally, you have 1 by 10. So the probability complement is 9 by 10. So 2 by 3 into 4 by 5 into 9 by 10. This is the value. So if you simplify, it comes to 3 3s are 9, 2 5s are 10. So I'm getting 4 3s are 12, and in the denominator I'm getting 25. So I'm getting 1 minus 12 by 25. So the answer is 13 by 25. The answer is 13 by 25. This is how we solve it using variation, and the variation is by using the De Morgan's law, which is A union B union C complement is equal to A complement intersection B complement intersection C complement. Okay, that is how we solve it. Yeah, the answer comes to 13 by 25. That is, 39 by 75. Yes. 39 by 75. Priyanka, you are right. Correct answer. Okay. Okay, last example, let me see. Nikhil, this is an example from conditional probability. So you can see 20 males and 15 females. You have 12 males and 8 females are service holders. So from there you can find out the males who are service holders. 12 males are service holders. So 12 by 35. Why? Because total number of people are 20 and 15, 35. So the probability that you are a service holder and male is 12 by 35. And the probability that you are only male is 20 by 35 because 20 males are there out of 35 people. So if you just divide, you are getting 0.6, and this is an example of conditional probability. Okay, that's how we solve this. 13 by 25. Yes, many of you have got it. Anchal, Shiba, Naveen. Okay, 13 by 25. So this is the De Morgan's law. Basically, I'll just introduce the law itself. Later on, we will see the presentation also. In that also we'll discuss. So basically it says A, B. So A union B intersection is equal to A union B complement, is equal to A complement intersection B complement intersection C complement. So this is basically what the law says. A union B complement means the other area, the shaded area. The shaded area is A union B complement. So this is De Morgan's law. De Morgan's law. So this is A union B complement. So this, if you see, is basically equal to A complement. A complement means outside A whatever is there. Okay, A complement intersection B complement. Again, B is here. Outside of B whatever is there. If you find the common areas, common portions of both A complement and B complement, you will get this particular A union B complement. You can get it. So this formula which you see is A union B complement equal to A complement intersection B complement. So for particularly if you have three such cases, like here we have three cases, PA, PB and PC. So it will be P A union B union C complement. That will be equal to P A complement intersection P B complement and intersection P C complement. Okay. So We can find out the complementary values also, because for each of them the probability is given. So when the first probability is PA equal to 1 by 3. So if you find out the complement, it will become 2 by 3, 1 minus 1 by 3. Second probability is 1 by 5. So if you want to find the complement, it will be 4 by 5. And the third one is 1 by 10. So the complementary value will be 9 by 10. Okay, so you just multiply. So the complementary values are 2 by 3 into 4 by 5 into 9 by 10. So 3 3s are 9, 2 5s are 10. So you have 4 3s are 12, and in the denominator you have 25. So you get the answer 1 minus 12 by 25, that is 13 by 25. Okay, right. I'm sure you are clear now. 13 by 25, yes. Now we go to the last few questions. This formula we have seen, all the formula in one place. PA, probability of any event, is equal to the number of favorable probability which are favorable to an event divided by the number of total events. Mutually exclusive means we know PA union B is equal to PA plus PB. There is no intersection because intersection area will be 0. And for non-mutually exclusive events, if there are cases where there is a non-mutually exclusive case, then it will be PA union B equal to PA plus PB minus P intersection B, and conditional probability we have checked, and that is PA by B is equal to PAB divided by PB. Okay, now we go into the last few questions from the MTP. This is a question from the mock test paper. An investment consultant predicts that the odds against the price of a certain share stock going up is 2:1, and the odds are in favor of the price remaining the same is 1:3. What is the probability that the stock price will go down? Very intelligent question. It's good that we could also complete so many types of problems, and additionally we have completed discussion of the De Morgan's law. Gautam is asking whether area of B will be counted in a complement. Well, if it is B complement, once again, I'll show you Gautam. Say A and B. If this is B and this is A, B complement means all this area outside B. B will not be touched. You can see the entire area outside B. I'm just making checks, drawing checks here. Excepting B, all the area outside B, this is B complement. Okay, so this is B complement. I hope you have got it. Okay, now let me, Ankit, we will take the calculator tricks later if possible. There will be some, there may be there may be some 1 or 2 sessions, additional sessions for revision. In that session, we will take up some of the calculator tricks because we have to complete the curriculum which is given. Later on, we will take it up. Okay, now an investment consultant predicts that the odds against the price of a certain stock going up is 2:1. The odds against the price of a certain stock going up is 2:1, and the odds are in favor of the price remaining the same is 1/3. What is the probability that the price of the stock will go down? So this is a question of odds in favor and odds against. So the question is odds against the price of a certain stock going up is 2:1. That means the probability that the price of the certain stock going up, odds against the price, not odds in favor. So that means the probability that the price will not go up is 2/3. So I'm writing probability that the price not going up is 2 divided by 2 plus 1, that is 2/3. And it is given that odds are in favor of the price remaining the same is 1/3. So I can say that the odds in favor of the price remaining the same. So the probability that price remains same is how much? It is 1:3. That means 1 divided by 1 plus 3. that is 1 by 4. So now the probability of the price not going up is 2 by 3, out of which the price remaining same is 1 by 4. So therefore, what is the other alternative which is possible? The other alternative possible is price will go down. So the question is, what is the probability that the price of the stock will go down? So the probability, please see, the probability of the price not going up is 2 by 3. Price not going up means there are two events. See, this is an example of composite events, which I discussed earlier. Composite or compound, it can be broken down into two simpler events. First event can be what? It is not going up. That means there are two chances. First is you are remaining static. Second is you are going down. The price is going down. So here what is happening? Price is not going up. The sum is 2 by 3. It can be broken up into two ways. First is price remains same. What is the probability? 1 by 4. And the other option is that the price goes down. So I'm writing goes down. This is x, which we need to find out. So I can write x plus 1 by 4 is equal to 2 by 3. X plus 1 by 4, x plus 1 by 4 equal to 2 by 3. Therefore, from here you can find x is equal to 2 by 3 minus 1 by 4. That gives us 4 to 8 minus 5, 5 by 12. Answer is 5 by 12. Okay, good. Okay, Gautam, please check once again. Just do it, just do that problem once again. In De Morgan's law, B will be counted in A complement and A will be counted in B complement. The question is, it will be the intersection of these two areas. Okay, just find out. It will be the intersection of these two. You draw it yourself and you will understand. Okay, always try to draw. Whenever you are drawing, you will get the idea. A and B. A and B. Okay, so it is true. What you wrote is, the first part is true. The first part is saying that in case of B complement will be this entire part. Excepting B, all the other areas. And A complement is all the parts excepting A. So it is true which you wrote, that A complement will be counted in B. A complement will be counted in B. Yes, B will be included in A complement. Similarly, A will be included in B complement. But the question is A complement intersection B complement. If you do this intersection, you will find only the shaded area will be included. Okay, let's do it correct. Okay, Dhyanesh has finally said this chapter is not hard. I hope you have understood. Good. That is what I told you, that if you approach it and listen to the session carefully, you will find it is easy. Jyoti, once again, I'm explaining 5 by 12. The question says that the probability that the price will not go up is 2 by 3. Okay, probability it will not go up is 2 by 3. So when I write not going up, right? So not go up means what? There can be two situations. First is staying where you are, same, and second situation can be going down. That is the share price going down. The probability that it is the same, it is given already, 1 by 4. And the total probability that it is not going to go up is 2 by 3. So 2 by 3, this probability, the probability that it is not going to go up, this event has two further events, sub-events. Price will not go up in two situations. Either the price remains same, and second situation is the price is actually going down. So in both the cases, it is not going up anymore, either remaining same or going down. You get the point. So you are in, say, for example, if I say you are in a mall. Okay, let me just draw here. So you are standing here, you are in a mall. You are, say, first floor, second floor, third floor. Second floor and third floor. You are here. This is an escalator. Okay, you are here. You are here. I'm just drawing. A person is standing here. Okay, the person is standing here. Now, if I say he is not going up, there can be two situations. Either the person is standing in the second floor or the person is coming down to the first floor. So situation number one, he is staying here. Situation number two, he is coming down. In both the cases, the outcome is what? He is not going up. So he is not going up can have two meanings. Either he's standing there or he's going down. So he is going down, that is the probability you have to find out. You know that if he is staying same, that means in the second floor, the price is remaining same, the probability is 1/4. And the total probability that you are not going up is 2/3. So what is the probability that you are going down? It is just simple, 2/3 minus 1/4. This total probability minus the probability that the price remains same. Okay, just see this example. You are here, you are not going up. It means what? That means either you are in the same floor or you are coming down. So here also, either you are in the same floor or you are going down. Right? I hope you have cleared. Shiva, thank you. Now you are getting this interest in this chapter. Well done. Okay. Oh, now this is also a nice question. You can see the type of questions we are taking now at the end, just 2-3 minutes more. So what is the probability of getting neither total of 7 nor 11 when the pair of dice is tossed? Okay, so what is the probability of getting neither total of 7 or nor 11? Okay, so when a pair of dice is tossed, how many total number of events can be there? It can be 6 into 6. Now the question says, what is the probability of neither total 7 nor 11? That means you will not get 7, you will also not get 11. So first we will find out the probability of getting 7 and 11. Okay. So 7, or I will say 7 or 11. So in how many ways you can get 7? So 4 and 3. 3 and 4 I will get 7. So I'm writing 7 and 11. For 11 only two ways, 5, 6, 6, 5. Sorry, I'll write 6, 5. 7 you can get in this way, 4, 3, 3, 4. Then 5, 2, 2, 5, 1, 6, 6, 1. Is there any other way for getting total of 7? 4, 3, 3, 4, 7, 5, 2, 2, 5, 1, 6, 6, 1. So you have 1, 2, 3, 4, 5, 6, 7 and 8. 8 ways are there. Okay. There are 8 ways of getting 7 or 11. So 8 by 36, that means 2 3s are 6 and 2 4s are 8. Again 2 2s are 4 and 2 3s are 6. So I'm getting 2 by 9. Okay. The probability of getting either 7 or 11 is 2 by 9. So the probability of getting neither 7 nor 11 is 1 minus 2 by 9. That is 7 by 9. Answer is 7 by 9. Great example. Thank you. Kashish, once again, I go back to that problem of that investment consultant. You are clear with the number now. Probability that you are not going up is 2 by 3. Once again, probability that you are not going up is 2 by 3. And probability that you are remaining same is 1/4. So what is the probability that you are going down? It is 2 by 3 minus 1/4. Just think once again. 2 by 3 minus 1/4. The probability that you are, I'm just taking like this, think of it in this way. The probability that you are not going up, you are in the second floor of the mall. The probability that you are not going up, say, is 30%. Okay, let me just write. Probability that you are not going up is 30%. And the probability that you are standing in the same floor is, say, 20%. Then what is the probability you are going down? 30 minus 20, 10%. Okay, I hope it's clear. And this is a beautiful question, very, very important question. What is the probability that a leap year selected at random contains either 53 Sundays or 53 Mondays? Classic question which came in the MTP. So you can get this question. What is the probability that a leap year selected at random contains either 53 Sundays or 53 Mondays? Now, 364 days are there in a year. So we are basically, there are 52 weeks. So 52 weeks in a year into 7, that gives you 364 days in a year. Now the 365th day and the 366th, this is the day, so this 1 year has completed. Okay, this is the 364th day. This is 365th day and this is the 366th day. The question is, what is the probability that a leap year? Leap year means 366 days. Okay, so 366 days. Leap year random contains either 53 Sundays or 53 Mondays. So you have 364 plus 2 days. Now either it will be Sunday or Monday. So in how many ways can you do it? Okay. So we can say Sunday and Monday. That means either it will contain 53 Sundays or 53 Mondays. That means either this one will be Sunday or Monday. So this situation can take place only when you have certain situations, like if it is Saturday, Sunday, then you get one Sunday. So I'm writing Saturday, Sunday, then you get one Sunday. The question is either Sunday or Monday. If it is Sunday, Monday, okay, either Sunday or either 53 Sunday or 53 Mondays. That is the question. Okay. If it is Monday, Tuesday, then also you will get it. Okay, if it is Monday and Tuesday, then also you get it. Right. So 364 days and 364 and there are 2 days more. So the question is, in how many ways can you get a Sunday? Sunday I will get when I have Saturday, Sunday, Sunday, Monday. Sunday I am getting when I have Saturday, Sunday and Sunday, Monday. These two situations. So there are 2 ways. 2 ways. Now out of 7 days, the probability therefore becomes 2 by 7. And the probability of getting Monday is how much? The probability of getting Monday is, it can be either Sunday, Monday, or it can be Monday, Tuesday. So for getting a Monday also, I am getting these two combinations, Sunday, Monday and Monday, Tuesday, again 2 by 7. But out of this, we have one combination that is Sunday, Monday. That means both Sunday and Monday. The question is Sunday or Monday. So ultimately the question will be 2 by 7 plus 2 by 7 minus 1 by 7. That is probability of A plus probability of B minus probability of AB. So we are deducting the common part. 2 by 7 for getting Sundays, 2 by 7 for getting Mondays, and 1 by 7 is basically the probability of getting Sunday and Monday, but that is not required. So we are deducting it, right? So the answer is, we are getting 2 by 7 plus 2 by 7 minus 1 by 7. So it is 3 by 7. Okay. This is the last question. And the question is, if P, this is an MTP question, if A and B are 2 events such that PA is 1/4, PB is 1/3, and PA union B is given, what is PB dash A, B slash A equal to? Okay, this is the last question with which we are completing the chapter, the first part of the probability chapter. A and B are 2 events, it is given, PA is given, PB is given. So if PA is given and PB is given, you can easily find PAB, because PAB is equal to PA into PB. The probability is given, we will write it 1 by 4 into 1 by 3, that is 1 by 12. So we know PAB. We have to find PB by A. PB by A is equal to PAB divided by PA. We have to find that. Now the question is, PAB we have already got, but then PB by A is how much? PB by A is how much? So here you can just take it like this. PB by A is equal to PAB, that is 1 by 12 divided by PA. PA is given 1 by 4. So divided by 1 by 4. So 1 by 12 into 4, that is 1 by 3. So we are getting PB slash A, that is PBA means probability of B given that event A has occurred. That is PB by A, that is the conditional probability, right? So this comes to 1 by 3. Okay, finally, the last one which I'm sharing, last question from Ananya. Kindly share some tips and tricks to answer questions quickly. See, the tip is very simple to ensure that probability of passing is 1, which is there on the slide. So formally we complete the session, but I will just tell you that there is no secret. The tip is to practice all the questions in the suggested the mock test paper number 1. Please complete answering all the questions in the exercises, which we try to do as many as possible within the time allotted. We try to complete as many questions as possible. We take questions from the AQB also, so please do that. All the exercises, set A, set B, and set C. If there is an additional question bank, please do that. And at the end, from the mock test paper, please practice. Definitely, you will have a higher chance of passing. And definitely, in the coming days, you'll be successful in the exam. It's only about practice. And there is no shortcut. The more you practice, the quicker will be the thinking. So you will be able to crack the problem in a lesser amount of time. There is no other shortcut. In mathematics and statistics, no other shortcut. Formula you have to remember. If you forget the formula in the exam hall, then there will be trouble. Okay, so please remember the formula and as much of practice as possible. In mathematics, at least I don't know of any other shortcut. Right? If there is a formula, you have to use the formula. Like for this problem on probability, there is no other shortcut. The formula is simple. It's a very simple formula. But then you have to understand the problem. That is intelligence part. So mathematics, some people feel that there are some quick secret tips. No secret tip. At least that's something which I don't know at least. The simple point is practicing until and unless your speed, you can look at the question and understand what will be the process of answering. That is most important. This is only possible when number of problems of each type has been practiced, so that you develop your confidence, your understanding, your concept becomes clearer, and it will lead to faster processing, right? So just go on practicing and you will find that is the only secret in mathematics and statistics. And it will also ensure that you remember the formula and you are able to apply the knowledge in a given situation, right? So with that, we come to you. Come to the end of this session today, and thank you, Jaspreet, Nikhil, and all the others. So thank you. We will meet on 28th and take up the last part of probability. Till then, keep practicing, and I'm sure you can work hard and make the probability of passing in the exam 1. That means 100% certain. Thank you. Bye.